Hey everybody, welcome back to the shop. So I am excited about this video. It's been a long time coming. I'm going to do my best in this video to explain the V-Carve inlay process. Now, I'm going to start off with some simple ground rules to help you achieve better success, if you will. And there's going to be a ton of information in this video. So as I say in the beginning of every video, this is the way that, or every tutorial, this is the way that I make these projects. This is the way that I do the V-Carves. Now there's 100 different ways of doing it, but I'm going to try to simplify this process so that it's easier for the layman to understand. Layman meaning me, you, and the people out there that are just getting started with V-Carve inlay. Now to begin with, let's start off with the few ground rules that I said I'm going to lay out for you. And we're going to start that by turning to the mill. So one of the most important things you can do, and one of the first steps that you must do, is surface your wasteboard. And as you can see, my wasteboard has a section in the center that I've flattened. Your projects and your board, it's imperative that they're absolutely as flat as possible. The next important step is tramming your spindle. And the reason for the tramming is, well, let me take this pencil and try to illustrate and explain why tramming is important. If this is your V-bit and your spindle is out of tram or not correct, picture your V-bit in this angle. This is an abstract angle, but picture this. Now as it passes through the wood and passes over your design, it's cutting more material on this side than it is on this side. And when you go try and put your male piece into the female piece, you're going to have a gap that runs all the way around the one side. So, surfacing the wasteboard, tramming your spindle, two very important first steps. Okay, something else I discovered while tramming my very own machine. If you own a Carveco XXL, I discovered that just the slightest amount of pressure leaning on this machine will cause it to bow in the center. And I know that's an ongoing issue that Carveco's had. So word to the wise, don't lean on your CNC machines while they're running. Resist the temptation to lean in and see what's going on with your carves. Okay, now that we've gone over the basics for the machine, we're going to go over another little topic or another little point of this. Again, all these points are to help you succeed with your projects. You want to pick the correct species of wood. You want woods like black walnut, cherry, maple, canary. Not that canary. And you also want to do end grain boards if you can. Without getting into a long drawn out reason why, it just, trust me, it works better in an end grain board, cutting board, charcuterie board, whatever other kind of board you'd like to do. The V-Carve inlay process, you will have more success with an end grain. Like I said, this video is going to have a ton of information in it. So, moving forward, after you make your stock pieces, your male and your female pieces, you have to surface those as well. I can't stress enough the importance of having a flat wasteboard and flat male and female pieces to make this work. So load your pieces in, surface them, and you'll be good to go. Okay everybody, we're back to the computer now. And before we get started, I want to tell you that this is going to be a basic tutorial. I'm not going to go into the detailed explanation of why we're choosing the settings we're choosing, why the numbers we're choosing. There's a couple of great videos out there, one by Chad Bookerman and one from Leighton from Carveco. Chad's channel is BHL Woodworks, and if you want an in-depth reason why we're choosing those numbers, I'd suggest you go check out their channels. But other than that, we're going to get started here. We're going to open up our old friend Carveco. And we're going to go to New Model. We're going to choose 6 inches by 6 inches. We're going to work in inches. We're going to leave the resolution cranked all the way up. We're going to put our origin in the center. Click OK. Alright, now it opens up into 3D view, and to make things easier, let's switch over to the 2D view, which is this tab right here. Obviously the paper turns white, and we're ready to go. Now we need to load an image in here. Now when I load images, I go to the internet and I search for line drawings of any image I want. I don't convert photos. I know how to do that, but we're not going to show you that here. That gets too complicated. So you'll go to the internet and you'll search a line drawing and put free on the end of it. Don't choose images that you have to pay for unless you're willing to do so. Those artists work very hard on their drawings. They deserve to be paid if they make them and they're asking to be paid. But in this case, I chose a free image and it's on my desktop. So we're going to grab that image and we're going to bring it in here and put it on the work surface. To do that, click on bitmaps over here. Click on this folder here. And we're going to choose this image here, and I named him Leo. So we'll click on that and it gives you a preview of the file. One step you do not want to forget is down here in scaling. You're going to click on the drop down and you're going to choose fit. Select fit, click open, and bing bang boom, Leo is on the paper. Alright, now we need to make some vectors. So the simplest way to do that is to go here to the top, to this icon, bitmap to vector. Click on that icon. You'll be greeted with this drop down over here. First thing we need to do is reduce the colors. If you look along the bottom here, there is a tremendous number of blacks in here. Doesn't look like it when we look at it, but that's what the computer sees. So click on Reduce Colors. And we're going to take this back all the way to number 3. 3 colors is what we're looking for. Click Apply. I want to show you something particular about this. If we zoom in, you can see that there is indeed 3 colors here. White, black, and a gray color here. What we want to do is combine the black and the gray so that when we create the vectors, it'll sharpen up the lines and it'll just make a nicer vector for you. So in order to do that, we go down here to this corner, and as you can see, we have a black box and a white box. What we need to do is get this gray color where this white position is. And in order to do that, we need to click on this arrow, and now you can see that it has inverted those 2 colors. But we don't care about that. Click on the gray one now. That puts the gray one on the top. We're going to click on this arrow one more time to invert those 2. Then we're going to click on this chain link. Now before I do that, this is going to combine the 2 colors. I don't want you to watch me clicking this. I want you to look up in here somewhere and watch what happens to this gray color when I click on those chain links. I'm going to count to 3 and do it so you can pay attention. 1, 2, 3. And as you can see now, the gray is gone, the black is there, and the lines are much, much sharper. So we'll pull this down into the center. And if you're wondering how I just did that, pardon me, I'm clicking on both, or I'm holding down both mouse buttons, and I'm dragging the mouse around, pulling the image where I want it. Alright, so we've reduced the colors. Now we need to create the vectors. You're going to create a boundary. You want that selection checked. Speckle size, you're looking for a 2 to 5. Speckle size determines how precise the computer looks to create the vectors along these lines. The higher this number, the more precise, the more jagged your vectors will be. So keep that number low, 2 to 5. Smoothness is 75%. That's fine. Primary color is black. Let's create some vectors. Click Create Vectors. Alright, now we know they're there. We can see there's some blue in here. But let's back out just a click. Close the bitmap to vector dropdown. Alright, now let's see. We have what appears to be vectors. How do we know that they're really there? That's simple. Go back over here to where the bitmaps selection is and click on these light bulbs. It takes away the color and leaves you with only the vectors. So there's your female part. Actually, that's your female component for this carving. Now what I like to do is, this is a 6x6. I want to utilize as much space as I can on the work surface while leaving myself roughly 1/4 inch all the way around. Now if you were doing a very specific size inlay, you wouldn't do this next step. But in this case, I want to get this inlay image as large as I can while leaving myself space around the outside edge. And that will pertain or have to do with the male. So what we'll do in this case, we've got all the vectors highlighted. We'll go over here to the spinning throwing star. Click on that. That's not really what that's called. That's a transform tool. We'll go back over here to this side, and we will change the size of this image numerically. Now, the one thing you want to make sure of is that this lock is turned on. If you happen to click on this lock, you can see that the lock disappears. What will happen is it will distort your image if you change one of these numbers. This number and this number will not act together with that lock off. So click the lock back on. Now we know this is a 6-inch high piece of stock, and the image is obviously taller than it is wide. So let's just go by the height dimension and say if I do 5.5 inches, that leaves me 1/4 of an inch on the top and 1/4 of an inch on the bottom. So back over here, we will change this number to 5.5. And as you can see, the width changed. It adjusted automatically. Click apply, and Leo just got a little bit bigger. All right, we can close out the transform tool. We no longer need that. Okay, so here's where we'll start throwing in the tricks and the curves for you. The part that I feel that a lot of people get confused by. And before I do that, I want to mention that once you have this process down, I highly recommend that you make a inlay storyboard. And I'll show more on that here later, but let's continue with this. All right, so we have the female. So here's where the confusion, I think the confusion starts, but we're going to try and simplify this as best I can for y'all. All right. What we need to do is go to the top and click Save As, and we need to save this as Leo Female. Always name the first female part you're working on as the female, because this can it'll get you discombobulated if you don't keep it straight. So click Save. Now here, stay with me here. Minimize the screen. Open Carveco again. Wait a minute or two for it to load. New model again. Same exact size. Everything will be identical to what it was on the female. What you're doing is creating a separate file for the male now. Origin in the center. Click OK. It opens up just like before in the 3D view. Switch it to 2D view. Now what you're going to do is minimize this screen. What this has done is created two separate workspaces that you can jump back and forth between the two. Obviously this one's the female, the male is not existent yet, but we're going to correct that here in just a little bit. So open the female back up, hover over the female and right click your mouse. You're going to copy the female. You're going to minimize the screen. You're going to bring up the second work surface. You're going to hover in the center of the work area, right click, and you're going to paste down. Oh, there's Mr. Leo again. He's back. You're going to hit F9 to ensure that he's in the center. And then this next step is super, super important. If you don't do this step, it will not fit in the female. Come over here to this side. You're going to click on this icon, Mirror Objects. Again, I keep saying this over and over again. This is where people get confused. I'm going to simplify this as much as I can for you. These two selections do not get selected. They are not checked. Do not select any of these selections or this one. You're looking for center right here. This is the only button you need to click at this point to what we call mirror the image. If you pay attention to this Leo, when I click this button, he's going to jump. So again, don't watch my cursor over here. Watch Leo. I'll count to 3 and see if you can catch what happens. 1, 2, 3. You just created the male. That's all there is to it to create the male. There's a few little other intricate things we've got to do here, but let's go back to the female now and get that finished. Then we'll come back to the male to avoid confusion. So minimize. Oh, let me back up. I almost made a mistake. Go up here to File, Save As. See, we have Leo female. Now, as you may have guessed, we're going to create Leo male. And as I say, we do this to avoid the confusion when we're jumping back and forth between female and male, female and male. We're going to continue with the female here. Female is very basic. It's just a simple V-Carve. Go up here to the top, click this icon, create V-bit carving toolpath. We've already got the vectors selected, so we don't have to do anything there. And here's where the numbers come in, where people start to get all antsy and they get confused. Again, I'm not going to explain why we're putting these numbers where we are. I'm just going to tell you where to put these numbers. So your start depth is 0. You're going to need to select Limit Tool Maximum Depth. Select Limit Tool Maximum Depth. That maximum depth will be 1/4 of an inch. Rarely will you ever need to make an inlay deeper than 1/4 of an inch. Tolerance at 0.001. That is the female settings for your cut depth. It never changes. You never have to change it. So that number is put in every time. Go down here to click to select tool. Okay, so let's click this to select the V-bit carving tool. We're going to come over here and choose the V-bit 1/32 tapered ball nose. Now, when you do your carving, you're going to use the same bit, the same angled bit on every piece, male or female. And in this case, this one is a 12.4 degree V-bit. One other very important point, when you receive your tool, your V-bit, and you're going to enter it into this database, do not enter it as an end mill or it will not work. You need to lie to the machine and tell the machine or the database that the bit you have is a V-bit, not a ball nose, not an end mill. This bit will now become a V-bit 1/32 tapered ball nose. Select the tool. Click on the tool once more. We're going to change the tool number to tool number 2. And we're going to scroll down and then select a roughing tool. Now before I click on that roughing tool, I want to explain something here. We're going to use, on this image, we're going to use a 1/16 inch end mill. Typically you would use a 1/8 inch. However, because this image is so small, a 1/8 inch end mill will not pass in between those vectors right there and right there. They're just too close together. So if you remember this, a tiny inlay, we use a tiny bit. So we're going to go with a 1/16 to do this. A word of caution here. With a 1/16 inch end mill, you're going to need to slow the feed down considerably. Slow it down to 10 to 20 inches per minute, or it will break the bit. Whenever possible, create a V-carve that is large enough to accept an 1/8 inch end mill and avoid using a 1/16. If this was a larger image, then we would use the 1/8 inch and we would be fine. And that gets into a little bit more of an advanced discussion on how to change the vectors and move things around. Again, we're not going to get into that in this video. If there's any interest in that, I can create a more advanced video. Just leave a comment in the comment section below. And if there's enough interest, I'll create another video. Anyway, down to the roughing tool, click to select. Like I said, we're going to come over and use a 1/16 end mill. Select that tool. Continuing down. Safe Z height is 0.2 or 0.25. That's correct. We need to define the material, and in this case, I'm going to choose a 1-inch piece of wood. We'll go down here and we'll name this Leo Female. And we will create the toolpath. calculate now. All right, looks pretty cool. Let's close that out. Let's simulate the toolpath just for sake of argument. And you push down on the space bar and you left click and you can rotate, and as you can see, we have the female now. It is cut out. And if we zoom in, because we used a 1/16 inch end mill, it was able to get into these little areas here where the 1/8 would not, and you would be left with a multitude of these little bitty carving lines in the bottom of your carving, and you would have to clean them out. So I suggest when you're doing this, choose the correct size end mill, and in this case 1/16. All right, click on simulation. We're going to delete the simulation. Going to hit this box up here to square this back up. Hit this to bring the lion back. Switch back to 2D view. We can actually turn off the tool paths if you don't want to see those. And that is the female. Okay, so now we need to save the tool paths. We'll click on this icon to save tool paths. And we're going to save this in such a way that if you don't have a bit setter, you can still do a 2-tool carving. What you're going to need to do is, obviously we have tool number 1 and tool number 2. Click on tool number 2. Click on this arrow and bring this over to this side, which I call the inactive screen. This is the active. We're going to create a file called Leo Female Tool Number 1. We're going to save that. Now we're saving to the desktop here, and if you need to change this where you're saving that, you can click on Change Spool Directory and you can browse the file and find where you want it. So now that we have the male file created, let's select this one more time, bring it back to the active area. We'll select tool number 1 and take it to the inactive area. And we will, now, you guessed it, we'll save it as tool number 2. We'll click Save. And as you can see, they are on the desktop. Leo Female Tool 1, Leo Female Tool 2. So you'll load your material into your mill. You will load your end mill in. You will zero just as you did traditionally. You'll select this file, hit go on your mill, and it will carve out the roughing pass. Then you will select the end mill, the V-bit, the V-bit. You will only zero for Z with the V-bit, correcting your Z height 0. Open this file, run the V-bit, and your female will be complete. Let's move on to the male. Okay, so here's the male. Now buckle up, this is where people get confused, but we're going to make this as simple as possible. Now what you need to do is create a border around the outside edge of the image greater than the points that are sticking out. Roughly 1/8 to 1/4 of an inch. Now I have grouped these vectors, so if your vectors were not selected, before you begin, select all of your vectors, go to this icon over here, click on it, and group your vectors. By now, if you're doing a V-Carve, I'm sure you know how to group your vectors together. So group the vectors, click off of the image, click on the square. We're now going to create the border around the outside of this image. And we know we only have 1/4 of an inch from here to the top and from here to the bottom because in the beginning we changed the size. So let's start right at the top and we'll drag down and to the right all the way to the bottom. Don't need to be that wide. We'll release, create the square, hit F9 to put the square in the middle. Go back to your normal arrow cursor and select off of your image. You now have the border that you need to create the male. If you don't put this border in, you're just creating another V-carve that's the mirrored backwards of the female. What we're trying to do is remove this area in here and everywhere in between to make the vectors now stick up off of the board. So you're removing material along the outside. And this is basically all you need to do to create the mail. We've got to put some fancy numbers in, but that is your mail. So if you highlight everything and go back to your V-bit carving, open up your tools. Now these are the numbers that we're going to enter in here, and they're not going to change. Your start depth now is 0.2 every time. 0.2. You're still going to limit the tool depth, but this time your maximum depth is going to be 0.05. Now, having said that we're not going to change any of these numbers, we need to realize, or at least I firmly believe, that each CNC, each mill behaves differently than somebody else's. Do not change the start depth, but you can play with the maximum depth number to adjust for the differences between mill and mill. Getting back to what an inlay storyboard is, when I started this, I took this maximum depth number, I took the recommendations from the videos that we watched, and I loaded this number right here, 0.05. I then created 4 more carvings where I changed this number until I got the desired effect. Once I've finished this portion of the tutorial, we're going to go back out to the shop, and I'm going to show you that storyboard, or inlay storyboard, and I'm going to show you what happens when you change just this number. This number should range roughly 0.05 to 0.09. Should get you very, very close to what you're looking for. Again, if you create a storyboard, do everything else the same and just change this number up or down until you achieve the perfect fit and the perfect distance off the bottom that you're looking for. But a starting point, a good starting point, is 0.05. So we'll continue down. We'll collect and select the carving tool. Again, it's the same exact tool we clicked before, the tapered ball nose. Select that tool. Open it back up again. Just like before, we change it to tool number 2. We confirm that all of these settings are the same as they were on the female. They're correct. We then go down and select a roughing tool. Again, it's the same tool we used before, the 16th inch. We select that. We continue down. Same safe Z height, same material height. You can use shorter material for the male because you're going to cut off a considerable amount of waste. So you could say this is a 1/2 inch tall, but we're not going to do that in this case. Let's call it a 3/4 inch piece. One too many numbers in there, Vernon. All right, click OK. We'll call this, as you guessed, Leo male. Once again, we will calculate the tools. And just by doing that, you can see it's carving away all of the things that we don't want to create this raised portion in white. Let's close out the V-bit carving toolpath. Let's simulate this so that I can prove to you that we do have a male. Click on simulate. Simulate there. Push down the space bar and rotate the image. And as you can see, we now have a raised Leo the lion on this board. Very simple to do. Pushing the space bar again, rotating it back. And what we will do when you do your male is you'll carve this male out. Let's center this up here. You will carve the male out. Then you'll take this piece to your bandsaw or your table saw, and you'll run your saw through here. You'll run your saw through here, and that will leave you with a raised portion that is just the lion. and that's what gets clamped into your female. Which brings me to another very, very important point. Clamping pressure is paramount. You have to have adequate clamp pressure to make this work on any of these inlays. As I said in the beginning, Chad Bookerman has an excellent video. I believe he also has a clamping fixture that he's happy to show you how that works. If you message him, he'll help you out with that. I happen to have created a hydraulic press that I'm using to do these with. I may make a video that shows how I did that as well. But anyway, we now have the male. And as I said, if you change that one number, you can change how tall your male piece is. So let's go back out to the shop now, and I will create the carvings, and I'll show you what happens when you alter just that one number that I talked about in the beginning there, or back a little bit. Go back through, save your tools just as you did the female, creating two separate files, one for tool number 1, one for tool number 2. They'll show up on your desktop. You'll go out to the mill and you'll do the same thing as you did with the female, and in this case you'll end up with a male. And I hope that you're getting something out of this video. I hope it's helping to clarify this a little bit. But let's go out to the mill and I'll show you what a storyboard is, an inlay storyboard, and I'll show you what happens when you alter that single number that we talked about, just so that I know you're clear. I'm talking about this number right here. When I show you the images or show you the pieces, I'll have only changed this number, increasing it or decreasing it. But again, maximum depth 0.05 is a great starting point. And don't think for an instant that your first carve is going to come out perfect, because there's going to be issues with it. But hang in there and continue to work at this, and when you get it right, it's just awesome. All right, so we're back out in the shop, and I want to explain what a storyboard is. And that's over here on the mill. A storyboard is nothing more than identical images cut in your test piece. As you can see, we've got old Leo here in 4 times. What we've done after that is we create the males, and we alter the males so that they are a different thickness each time. And in this case, I went 05, 07, and 09, and to show you truly what happens when you change that single number we talked about, I went 0.25. As you can see, the wall is paper thin. The raised V section of the male is almost a ½ inch thick. Now, through the magic of YouTube, I'm going to pop them in there quick, glue them in, and then, believe it or not, we're going to take the table saw and we're going to cut right down through the center of these. And we're going to get a good look and see how far in these males recess into these females. And that is the object of the storyboard, to tell you what your machine likes for numbers. So let me snap my fingers here and put these back together, or put it together, and show you what we get. There you have it. Let's cut them in half. We can see the picture on the inside. 05 and 07 are obviously the two that work the best with my machine. Some voids here, that's unavoidable. That's micro zero adjustment. Maybe the board moved a little bit. 09 is too much. It's mashing the bottom here. And 25 is ridiculous. Okay, there you have it, everybody. I hope you enjoyed the video. I hope you got something out of it. I hope it helped somebody maybe get rid of a little bit of the confusion. Again, check out the other folks' videos on this stuff, because it's pretty complex, it's pretty involved, but I'm hoping that I've got it cleared up for you. As always, give us a like, a share, and subscribe, and we appreciate that. A few parting words: tram your machine, surface your wasteboard. Try to avoid using a 16th inch end mill to do this if at all possible. Always use the 18th inch. And if you do have to use a 16th inch, slow your feed down, way down, maybe even less than 10 inches per minute. And as always, we'll catch you on the next one.